Okay, so today's goal is we're going to look at a couple other algebraic techniques. Let me grab a pen. Okay, you're going to see this one next year in calculus a lot. It's kind of like the slope formula for 1 point, so we use that a lot. And I didn't do so much in the Google Doc, so I want to make sure everybody's okay with how you write stuff. Okay, so how do you know you got to do something fancy? You kind of want to just evaluate the expression at 0. So h is going to 0. So you'd have x squared minus x squared over 0. So you're like, bam, 0 over 0, you got to do something. Okay, so this time we can't really factor. So what we are going to hope is that if we expand, things will cancel out or reduce out. So when you expand a square of a binomial, you have this. And then you subtract x squared. So this is the first term, and that's the second. And then you have over h, and you notice that these guys cross out. And now we're going to write the limit again. So you keep on writing this limit notation until you can evaluate the limit by either swapping in where the x is going or by using one of those basic forms. Okay, so we're going to check again. So if you put in 0, you would still have 0 plus 0 over 0. So you're like, I still got to do something else. That's how you know. And you'll notice that you can factor out an h here. So let's try that. So the limit as h goes to 0, factor out the h. You have a 2x plus h over h. And this is a lot of times what you want to happen. These h's reduce out. And so now the new thing you have left for the function, you actually can just plain out evaluate it at 0. That's kind of your goal. You're trying to keep on doing stuff to the function so you get an equivalent version that you eventually can evaluate. So now we're going to just take this expression and we're going to swap in h is 0. So we keep the 2x, but the h is 0, and that's the same as 2x. And so think of me next year when you learn that the derivative of x squared is 2x. Okay? And sometimes you get some trig ones. And so, oh my God, let's go back. Remember when this was so hard for you? So first thing, check to see if it's just a nice normal point. So if you plug in pi, you'd have the tangent of pi over the sine of pi. And pi, you're here. So tangent slope, so this is 0, and sine is height. So you're like, oh, this is a 0 over 0. So what can we do? Can't really factor, but we do know you can swap out sine, or excuse me, swap out for tangent. So that's sine x over cosine x, whole thing over sine x. And your hope is that nice things happen. So let's check it out. Okay, so we're dividing these. So when you divide fractions, it's sine x over cosine x times the reciprocal of that. Now we can reduce. So we've got, this is the limit as x goes to 0, and our new function, our equivalent version of the function is 1 over cosine of x. But now, this function, you can evaluate when x is 0. So we're just going to do that. Remember, that's your goal. So this is equal to 1 over cosine of, oh, hang on. Let me change this. Cosine of pi, cosine of pi, cosine of pi. So 1 over cosine of pi. And at pi, the cosine's -1. That's 1 over -1, which is -1. Yay.